Hello everyone and welcome to Keeru's online lectures. I am Keera Jamtani and today's topic is Hydrocarbons Part 2. In Part 1, we studied about the introduction of hydrocarbons and alkanes. In Part 2, we are going to study about alkenes. Coming on to alkenes. So, the unsaturated hydrocarbons which have double bond, they are alkenes. Their general formula is CN H2N. CC hybridization bond hybridization is 1.34 angstrom. They show sp2 hybridization because they are double bond. Now let's suppose this is satisfied by a single bond. So with one carbon there are 3 sigma bonds. 3 sigma bonds indicate sp2 hybridization. When alkenes are treated with chlorine, oily products are formed. Therefore, they are known as olefins because in Greek, olefiant means that is oil forming. They show position and geometrical isomerism. Chain, position and geometrical isomerism. So, in geometrical isomerism, we have cis isomers and trans isomers. Coming on to nomenclature. Now as we know, for n is equals to 2, we write eth. So CH2 double bond CH2 N2, so we will be writing ethene. Similarly, if we have CH3 CH double bond CH2, it will be written as propene because 1, 2, 3 carbon is there. CH3 CH double bond CH CH2, 1, 2, 3, 4 carbons are there, and in second carbon there is double bond, so it will be written as butene. Then CH3 C CH3 double bond CH2, so counting will be done from the carbon where there is a double bond 1, 2, 3. So in second position there is a methyl group 2 methyl propene. So this is how nomenclature of alkenes is done. Coming on to preparation of alkenes. So alkenes are prepared from alkynes, like we have CH triple bond CH. So in the CH triple bond CH we have to add hydrogen. So alkenes on partial reduction with partially activated palletized charcoal, this palletized charcoal is Lindelar's catalyst. So on addition of this hydrogen we will get CH2 double bond CH2. Now if we have butene like CH3 CH double bond triple bond CH3, that is butene we have. So butene, if we have to prepare butene, so if we are taking Lindelar's catalyst, we get cis isomer of butene, and if we are taking sodium in liquid ammonia, here we get trans isomer. The cis isomer indicates the heavy group on the same sides like C double bond C CH3 AH and this CH3. This is known as cis isomer. So when hydrogen will be added, this triple bond converts into double bond. So if we are taking Lindelar's catalyst, that is palletized charcoal. So if we are taking Lindelar's catalyst, we get cis isomer. If we are taking sodium in liquid ammonia, we get trans isomer. Trans isomer is the opposite groups on this the opposite groups on the side, like CH3 are on the opposite side, sorry. Coming on to preparation from alkyl halides. So like we have alkyl halides. So alkyl halides may we have like CH3 CH2 Cl. So alkyl halides, basically we have to remove HCl from here. So therefore we call this reaction as dehydrohalogenation because hydrogen and halogen is removed from this reactant, and this is also known as beta elimination. Hydrogen and halogen is removed from the reactant. This is also known as beta elimination. Now, why it is known as beta elimination? Like carbon is removed, chlorine is removed. So, hydrogen is removed from the beta position, therefore, it is also known as beta elimination, and this reaction takes place in the presence of alcoholic KOH. This alcoholic KOH is known as dehydrohalogenating agent, that is, it involves the removal of HCl. Thus, Cl and H is removed, so we will get CH2 double bond CH2. Similarly, if we have alkene which have 2 beta positions, if we have alkyl halide which has 2 beta positions. So, as we can see over here, this chlorine, the carbon which is attached to the chlorine is alpha carbon and this carbon is known as beta carbon. So, hydrogen will be removed from that carbon which has already lesser number of hydrogen, that is, here hydrogen will be removed from CH2. This rule is known as Sedzeff rule. So, the product formed will be CH3CH double bond CH3. So, this is how we prepare alkenes from alkyl halides. Coming on to the preparation of alkenes from Vessenal dihalides. Now, there are two types of dihalides. The one is gem dihalide and the other one is Vacinal dihalide. Like if you are writing like this CH3CH ClCl, when two chlorine group are attached to the same carbon, we call it as gem dihalides, and when two halide groups are attached to two different carbon atoms, so in that case it is known as Vacinal dihalides. So, in this Vacinal dihalides, this reaction is basically done with the zinc. Since over here there is removal of halogens, therefore, this reaction is known as dehalogenation reaction. Thus, the product formed will be CH2 double bond CH2 plus ZnCl2. Coming on to the last preparation of alkenes, that is from alcohols. So, we have like alcohol over here CH3CH2OH. This reaction is done in the presence of concentrated H2SO4. In this reaction, basically what happens, this OH and H is removed from the beta position, that is, there is a removal of water, therefore, we call it as dehydration reaction where there is removal of water. This reaction is taking place in the presence of concentrated H2SO4, therefore, we call it as dehydrating agent. So, when we are removing water from this reactant, we will get CH2 double bond CH2. So, this is how alkene is prepared from alcohols. Now, coming on to the physical properties of alkenes. So, the first physical property of alkene is physical state. First 3 members are gas, next 14 are liquids and higher members are waxy solid. Ethene, it is a colorless gas with faint sweet smell. Higher alkenes are colorless and odorless. Coming on to melting and boiling point, it increases with increase in molecular mass. Coming on to solubility, it is insoluble in water and soluble in non-polar solvents like benzene, hexene, carbon tetrachloride, etc. Density, it increases with increase in molecular mass. So, this is all about the physical properties of alkenes. Coming on to chemical properties of alkenes. In chemical properties, the first property we have, that is addition reaction. So, alkenes, they show electrophilic addition reaction. Like we have alkene over here CH3CH double bond CH2. So, the first reaction of addition which is performed over here, that is addition of hydrogen. If we are adding hydrogen, we call it as hydrogenation, and this hydrogen is added in the presence of catalyst nickel. So, thus we get alkane over here. This hydrogen will be attached to both of the carbon which are double bonded carbons. So, this is hydrogenation. The next addition reaction takes place with halogens, that is Br2, in the presence of CCl4 as a solvent. Again, the double bonded carbon atom will be attached with the bromine group, that is CH3, CH, Br, CH2, Br. We get over here Vacinal Dihalides. Now next is addition of hydrogen halides, that is addition of HBr. So over here we have H plus and Br minus. So here we apply the Markonef's rule. This Markonef's rule states the negative part of this reagent will go to the lesser number of the hydrogen having carbon, to the carbon having lesser number of hydrogen. So here we can see CH and CH2. These are two carbons which are with double bond. So the carbon with less number of hydrogen, bromine will attach to that group, and thus to the last group there will be the attachment of hydrogen ion. Now let us suppose in the same reaction they are giving HBr, but the presence of peroxide is given over here. So in peroxide we apply anti-Markonef's rule. Anti-Markonef's rule says the negative part will attach to the carbon having more number of hydrogen. So thus when it is Markonef's rule we get 2 bromo, and when it is anti-Markonef's rule we get 1 bromo, that is in the terminal carbon bromine group is attached. This anti-Markonef's rule reaction is also known as Kharash effect, or we can call it as peroxide effect also. So this was all about the addition reaction of alkenes, in which we studied hydrogenation, that is addition of hydrogen, halogenation, that is the addition of halogens. HBr addition is known as hydrohalogenation, that is addition of HBr, which follows Markonef's rule when peroxide is not there, but if peroxide is there then the anti-Markonef's rule is followed. There is one more addition reaction over here, that is addition of water, which indicates which says it is hydration. So addition of water is hydration, which takes place in acidic medium, that is H2SO4 with H plus ions. So here again the same Markonef's rule is applied. Negative part attaches to the carbon having less number of hydrogen. So this is all about, and so this is about the addition reaction of alkenes. Coming on to oxidation reaction of alkenes. So in oxidation reaction we have the first is combustion. Like let's suppose I have alkene over here, CH3 CH double bond CH2. So the first oxidation reaction is combustion. So alkenes on combustion they produce CO2 plus H2O. Next oxidation reaction takes place with dilute KMnO4, or we can say neutral KMnO4. So when we are performing controlled oxidation with potassium permanganate. So in this case what happens, the double bonded carbon will have 2 alcohol group. So the reaction will be CH3, CH, OH, CH2, OH, that is diols are formed. But if in place of dilute KMnO4 we take acidic KMnO4, so in this case this double bond breaks up and in both sides we get acids. So thus it will be CH3 COOH plus HCOOH, because this bond will break. So here also 2 carbon acid and this is 1 carbon acid. 1 carbon acid is unstable, therefore we write H2O plus CO2, that is it breaks up to form H2O and CO2. The last reaction and the very important reaction is ozonolysis. In ozonolysis this reaction is performed with ozone. So the double bonded carbon they are attached with oxygen, 3 oxygen atoms. So the attachment is in such a manner like this, CH2 and here O, O. So now what happens, in place of Zn, the cleavage takes place. Thus on cleavage, if we see over here, the product formed is CH3 CHO plus HCHO. Like over here in acidic amino-4, we said we get acids and H2O plus CO2 if one carbon acid is there. But if terminal alkene group are there, so we get ketone. Same is the case with ozonolysis. The product formed are usually aldehydes only for simple alkenes, and the bond breaks from here only, in this fashion only, that is, the double bond is broken and the two parts will give rise to a aldehydic group depending on the number of carbon atoms in the reactant. But if branched alkene is there, so we get ketone along with the aldehydic group. So in today's video we studied about alkenes, how to prepare alkenes, physical and chemical properties of alkenes. Hope you guys are finding videos helpful. So do like, share and subscribe the channel. Thank you.